off in example 3 yesterday, and as we left off, we talked about this ordered pair, right? Quick review here. We talked about this ordered pair being 5, 3. That tells me to go 5 right of the origin and 3 up. And so that gives me a triangle with sides 5 and 3. And then we found what we call the radius. It's the radius of the unit circle, or the radius of this particular circle that 5, 3 is on. Doing our Pythagorean theorem, we had square root of 34. Okay, and do recall that I suggested that you can always just use this formula. You don't have to think Pythagorean theorem to find that radius. Although, in all honesty, Pythagorean theorem we already have memorized. You know, memorizing another formula. But okay, these 6 trig functions. So I'm going to start off with sine. What do we know about sine of theta in this particular triangle?
It will be opposite over hypotenuse, so it's 3 over square root.
Okay, are you guys with her? SOHCAHTOA, yes, we mentioned SOHCAHTOA yesterday also. So sine is opposite over hypotenuse. So in this particular, and keep in mind, theta, your angle in question, is always on the x-axis and at the origin. Okay? After sine, I traditionally do cosine theta. So what's cosine? Okay. 5 over square root of 34 because it is adjacent over hypotenuse. And tangent of theta. What is tangent?
3/5.
Okay. 3/5 opposite over adjacent. Now, if I go set these up the way I was earlier this chapter, what am I going to put at the top of this next column? Cosecant. And why are we picking cosecant?
Because it's the opposite.
Okay, cosecant is our reciprocal function of sine. So if sine was 3 over square root of 34, cosecant is square root of 34 over 3. What do we put across from cosine? Secant. So secant of theta is reciprocal of cosine, so it's going to be square root of 34 over 5. And on those guys, figure out your own trick to remember them. I remember they're opposite of what you want them to be. Sine goes with cosecant, which starts with the opposite letter, right? S and C, C and S. Or cosine and cosecant, the two cos do not go together. Okay? And then last one, tangent. This is the easier one to remember. Reciprocal of tangent is cotangent, which is 5/3. Okay, not too bad, right? Maybe? Let's try B. Unless you had questions on A. Okay. As we think B, same idea, but slightly different. What's different? 5 is negative. So these are still X and Y. And, you know, as we learn about this, there's shortcuts we'll be able to take. But I am going to show you the triangle here and how it's a little bit different. In that, if this is my origin here, right? Where does negative 5, 3 go?
Negative 5 is and 3 is on this side.
Okay, so we're going to go left 5, so our x distance is negative 5, and then we're going to go up 3, so our y distance is still 3, yes? And we're going to that point that we can call negative 5, 3. Okay, and that point is on a radius, isn't it? So the only difference is we have a negative length on one of our sides. What about a radius? Is it going to be the same? Yeah, because when you put that -5 into the Pythagorean theorem or the formula I put for radius, you're going to square it. That's the first thing you're going to do. And so it's going to work just the same. So this r is still square root of 34. Okay, with that in mind, what changes here? Is sign going to change? Oh, by the way, pause. Where's my theta? Theta is at the origin on the x-axis. Always, 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 always. Okay? And obviously you see your right angle. Yes? I don't think I need to. The right angle I'm not concerned about, but theta is at the origin on the x-axis. Okay, so what's sine? Same thing as it was earlier? Still 3 over square root of 34. Okay. What's cosine of theta? Almost the same as earlier, except that it's -5 over the square root of 34. Okay. What about tangent? Okay, instead of positive 3/5, it is -3/5. Okay, reciprocal of sine is the function cosecant. And what do we know about cosecant? Square root of 34 over 3. Reciprocal of the cosine function is the secant function. What is my secant function?
Oh wait, square root of 34.
Okay. So it's square root of 34 over 5, and somewhere there's a negative, yes? Okay, it might happen to look like it's in front of square root of 34, but it's all the same, right? A negative out front, doesn't matter where it's at. And lastly, reciprocal of tangent is cotangent. What's my cotangent function? -5/3. So, as it's fairly obvious, anything that had a 5 became negative, yes? Okay, and what we're getting ready to learn down at the bottom part, okay, is that, well, and you can even see what it says down in the next part, but angles that are the same distance up or down from the x-axis, they're going to have the same numerical values to them. Okay, all of these 6 trig functions, even though this first one was in quadrant 1, this one we just did was in quadrant 2, they all had the same numerical values, didn't they? The only difference was, in quadrant 1, everybody was positive. And that's what we're getting ready to talk about. Everybody's always positive in quadrant 1. Okay, we're going to talk about that in my next piece. In quadrant 2, we threw in some negatives, didn't we? And in quadrant 2, we learned that sine and its reciprocal, the reciprocals always go together, was positive. Everybody else was negative in this case. So each quadrant has their specific pieces that happen. Okay? And in that case, in quadrant 2, sine will stay positive. Okay. Can I move on and talk about the next section then? Because this leads into it. Okay, key point right here. This is what I was just referencing. Angles with the same reference angle. And remember, reference angle is how far the angle is from the x-axis. Okay, and it's always positive, always less than 90. So angles with the same reference angle will have the same numerical values for the 6 trig functions. They simply have different signs based on what quadrant it's in. Okay, so we're going to put some information on this set of axes here. First of all, do you remember your quadrants? Quadrant 1, 2, 3, 4. Okay, these are in Roman numerals. You don't have to have them in Roman numerals. But remember, quadrant 1 is upper right. And like the unit circle, we go counterclockwise. Okay. I have a memory device for you. And that is that all students take calculus. Okay? That's my memory device. All students take calculus. As we look at all students take calculus, first of all, notice as I wrote those words, I went with the quadrant numbers, didn't I? Okay? And all. When we talk about all students being, or the all quadrant, that is that everything is positive in quadrant 1. It's the quadrant 1 where you go right and up. That means x is positive, y is positive, everything's positive, all 6 trig functions. In quadrant 2, students starts with s. What main trig function starts with s? Sine. So in quadrant 2, we know that sine is always positive. Now, my memory device only is based on the 3 main trig functions. Reciprocals go with their main trig function. So when I say that sine is positive in quadrant 2, that means sine and its reciprocal cosecant. Okay? Everybody else is negative. And that's what we just demonstrated on the previous example, right? Okay, all students take. What's the T? Tangent. So down here in quadrant 3, this is saying that tangent is positive. If tangent is positive, what else is going to be positive? Its reciprocal cotangent. And this means everybody else here is negative, so this means sine and cosine are going to be negative in this quadrant, and they're reciprocals. Think about, in quadrant 3, what do? You go left and you go down. So that means both x and y are negative in this case. And lastly, calculus starts with C. What main trig function are we talking about? Cosine. So in quadrant 4, cosine is positive, along with its reciprocal of secant. Okay? Now, this is a memory device I learned as a young calc teacher. Okay? You come up with your own memory device if you don't like mine.
What was Doug's? He told me.
No, because it's so bad.
I don't think I want to use Doug's because I don't think it was very,
It wasn't appropriate.
exactly.
It was Aunt Sally takes something.
I don't know.
Oh, Aunt Sally takes children.
Okay.
But that's not too bad for a Doug.
So, one of my first groups of calc students pre-calc students says, Amy Sargent teaches calculus.
Oh, that's pretty cool.
That was one that someone came up with early on in my pre-calc career. So, but if you don't like all students take calculus, then come up with something else. But this is the memory device. When we start talking about something, and I'm looking at you for a sign, I'm going to say, all students take calculus? Like, that's supposed to be your memory device. Is Jaren coming up with the Doug type ones that now that we don't want to hear? As I said, it's a you thing, right? Now I know what you were trying. I saw you have this weird look on your face, but
Well, I was trying to figure out
If she was yelling or
if it was a
something.
movie.
no. Okay. We got the idea of what we're talking about here, yes? Let's make it happen, okay? Now, A, B, and C, I can do with pretty much no work. I'm gonna show a little bit of work to help you guys understand and kind of help you connect it all, but there's really not work that has to be shown here. You could just give me an answer, and if you know what you're doing, that's doable, okay? So, determine the sign of the following without a calculator. Okay? In other words, do I want a numerical answer? No. I don't care about a numerical answer. You would have to have a calculator for these. These aren't nice, neat things. Well, secant of 5 pi over 3, when we know more, we can do it without a calculator. But, so sine of 147 degrees. What do you know about 147 degrees?
It is in the second quadrant.
Can we agree? It's in quadrant 2 because it is more than 90, but less than 180. Okay, that's how I reference everything, is I look at my 4 quadrants. That one's more than 90, less than 180. So, with that in mind, do you know the answer to the question before we go any farther? Disagree?
Oh wait, positive. My bad. I got them reversed.
Okay. What quadrant are we in? Quadrant 2. What do we know about sine in quadrant 2? It is positive. I know this answer without doing any work is positive. That's that memory device. Okay? Now, the math behind it real quick. Let me at least show you the math behind it. This was supposed to be sine, yes? So if you think about a triangle here, with your angle here, sine is opposite over hypotenuse, right? Are you with me? Haven't said anything too crazy. As you look at opposite over hypotenuse, I don't have numbers, but as you look at opposite over hypotenuse, opposite is right here. What do we know about that value that's going up? Is it a positive or a negative value? If we're going up, it is a positive y value. So that's going to be a positive divided by, what's the hypotenuse always? It's always a positive, isn't it? Because in this piece, you would do what? You would go left, which is negative. You would go up, which is positive. And the hypotenuse is always positive. Does that make sense?
Do you have to show work on these, or can you just write it down?
No, you don't have to show work. Because on this one, I think we can all agree, oh, yep, quadrant 2, all students take calculus, sine, we're good. Okay, now, B. Might need to show a little work on B because I'm not sure we're ready to do that one in our heads yet. Although, I do see people looking at the unit circle, so I guess we can, But, okay, thoughts here. What kind of things do we need to think about?
You have to convert it.
Nope, I'm not doing degrees.
Look at that unit.
I don't want you guys using that crunch. What I'm going to say, we can talk unit circle, but I'm going to try and get you to do it without just glancing at the unit circle. Because here's the deal, you don't always have the unit circle in front of you.
No, we have it beside us.
5 pi over 3. 5 pi over 3. Where is that in relation to 1 pi and 2 pi? So what is 1 pi in thirds? 1 pi is how many thirds?
1 pi.
1 pi is 3 over 3. Are you with? I'm not sure you're going to get. So the idea is over here where we think 180, right? Where our degree brains say 180. I'm trying to get you guys to realize that that is pi. I need your brainy brain to say, oh, that's pi. But we're working with a denominator of thirds. And so this is how many thirds? Can we agree that 3 pi over 3 is still pi? Okay. Now, over here on the right, this is my starting point and my ending point. Starting point is obviously 0. What's my ending point? 2 pi. 2 pi is how many thirds? 6 thirds. Okay? Long term, I don't want you just glancing at the unit circle. This is what I need your brains to do. Okay? Especially in calc. Okay? Those of you looking forward to calc, whether it be high school or college level, you've got to be able to do this eventually. Now, based on 3 pi over 3 and 6 pi over 3, where would you hypothesize that 5 pi over 3 is? Does that make sense? It's 1 away. So right here-ish is 5 pi over 3. So we do land in quadrant 4. Because think, guys, it's 3 pi over 3. Then we'd have 4 pi over 3, 5 pi over 3, 6 pi over 3. That's how thirds count. Okay. So, what do you guys know about secant? So this really is doing the reciprocal of the cosine of 5 pi over 3. So what's that say about the sign here? Positive? Because why? Yeah. All students take calculus. Okay? Right here, that means cosine and its reciprocal are positive. So this is going to be positive. Okay? You can also think of a triangle here. If we think of a triangle here, we just went to the right, and going to the right is positive. Then what are you doing? You're going down, which is negative. Hypotenuse is always positive. Well, we were doing the reciprocal of secant, so cosine. Cosine is, what's my phrase for cosine? Adjacent over hypotenuse, which is positive over positive. And then if you reciprocal that, that's still positive over positive, isn't it? Because technically for secant, we would have to reciprocal it. But now, can you just use the shortcut? Yes. However, I feel like if I don't, as the first time we go through this, explain why the shortcut is the way it is, you're not understanding, okay? So, tangent of 620 degrees. I know what my brain says about 620.
Minus 360.
Okay, 620 is too big to know, isn't it?
Yeah.
Okay, my brain says 620. It's bigger than 360. I don't want to work with it. So the first thing I'm going to do is I'm going to do 620, and I'm going to subtract off once around the circle. 620 minus 360 is?
260.
260. So now we're thinking tangent of 260. This is a point where you might not need to show work, right? 260 is more than what and less than what?
More than 180. Less than 260.
Okay, more than 180, less than 270. So 260 is something like that. All that really matters is that we know that it is in quadrant 3. All students take calculus. Positive? Because all students take calculus. This is the T quadrant. That means tangent is positive. Now, on this one, do realize here, okay, if I draw my triangle, if I go left, that means I'm going negative. If I go down, well, if I go down, that means I'm going negative. Hypotenuse is positive. That angle is always right there at the origin. Tangent is opposite over adjacent. Okay? What do you know? Opposite over adjacent is negative divided by negative, but what's a negative divided by a negative? That's a positive, isn't it? Okay? I know that. I realized that did not,
That's cute.
I don't know if that makes it any better or not, but, okay? Now, I'm not saying you have to draw out all these pictures and all the reasoning behind it. I just felt like I needed to explain that, okay? All students take calculus. Great quick way to remember it, okay? Or whatever variation of that you come up with. Okay. You have some work time. Let's use it.
On it.